morning, students. Myself P.B. Ingde, and today we have to engage the lecture number 45. Okay. Lecture number 45. So our today's title is what is effectiveness of a fin. Our today's title is effectiveness of. This is our today's titles. What is the symbol? The symbol is epsilon fin. This is the symbols, guys. Okay. So in yesterday, we discussed the efficiency of the fin, and today we will discuss the effectiveness of a fin. So what is the definition of this effectiveness of a fin? You see here, effectiveness of a fin is defined as it is a ratio of. Effectiveness of a fin, it is a ratio of heat transfer with a fin. Upon heat transfer without fin. This is called as the effectiveness of a fin, because we know that this is the diagram of the fin, guys. We already learned the fin very details, right? This is the fin diagram. Okay, we know that the heat is, this distance is what is, L is a length along the which direction, x direction. There is a base temperature, how much it is, T0. This is the surface. Okay, and this is the fin, and from the fin the heat is transferred. So what is our definition? Effectiveness of a fin, it is a ratio of heat transfer with a fin upon heat transfer without fin. So we already prove all this formula, and this is considered for a case, for which case, infinitely long fin. We consider for infinitely long fin, guys. Okay. So what is the formula for? Suppose this is our equation number 1. So for the formula Q with fin, heat transfer, what is the formula? We already proved this derivation, under root P H K ACS, okay, in bracket what is T0 minus TA, okay, and without fin, guys, what is the without fin? Q without fin. What is the formula, guys? H into cross sectional area ACS into T0 minus TA. Means in this is the formula, this is the heat transfer with fin. And in another position, what is, only we have to consider this surface, and but there is no any fin. So from this portion the heat is transfer is equal to what is HA into ACS into T0 minus TA. Okay. So suppose this is small equation, this is a capital 2 equation. So put this equation in equation number 1, guys. Yes or no? Yes. So put equation small 1 and equation small 2 in equation 1. So what is the change in formula? The effectiveness of a fin is becomes with fin means what is, under root PH K ACS into T0 minus TA, then what is divided by, what is the divided by, H into into ACS into what is T0 minus TA. Okay. So if you observe in this situation, what is guys, this and this becomes cancel. So what is remaining? The remaining term is under root PHK ACS divided by. So we write down in 2 times in under root H into ACS cross sectional area of a fin into H into ACS. Okay. So this term, this H and this will be cancelled. So what is remaining guys? The remaining is effectiveness of a fin is equal to what is under root PK upon HACS. Okay. Where is what is P? P is the perimeter of a fin. Okay, we know the K is thermal conductivity, A is the heat transfer coefficient, and AC is the cross sectional area of a fin guys here. So here if you observe in effectiveness, suppose if you consider this P by ACS ratio, suppose if P upon ACS means perimeter upon cross sectional area. So what is the perimeter formula? It is twice B plus Y upon cross sectional area, means it is the product of B into Y, because we know the diagram of the fin in 3 dimensionals. What is the diagram of the fins? The fin is in this way. We already learned these things. Yes or no? Yes. So inside this is the thickness Y. Okay. This portion is what is B, and this is what is the length of the fins, right? So this is the thickness, this P is the width, and L is the length. So perimeter means what is this one, and cross sectional area means what is this portion is nothing but the cross sectional area. This is the ACS cross sectional area. So here if you consider in a rectangular fin, straight rectangular fin, suppose the straight rectangular fin, okay, and the width is very greater, as compared to the thickness. Yes or no? Yes. So what is we getting here? If you consider this B is greater than this one, so what is the change in formula? The formula becomes, here we know that P upon ACS is equal to what is twice B upon BY. So this B is cancelled. So what is remaining here? You know, 2 upon Y guys. Okay. So effectiveness of a fin, the equation is changed. What is the equation change? Twice K upon HY also, right? So from this relation, two relation, this relations and this relation, what is we conclude that you see here effectiveness of a fin, is equal to the formula. We have the two formulas. I write down the first formula, this one, PK upon HACS. Okay. So what is observed here in some cases, suppose if you consider the first case, suppose effectiveness is greater than 1, and also the effectiveness is always greater than 1, or effectiveness equal to the 1 also. So if you observe is here, the effectiveness is depends upon the perimeters, it is depends upon the thermal conductivity, it is depends upon the heat transfer coefficient, and it is depend upon the cross sectional area of the fin also. Yes or no? Yes guys. So if you observe here, the effectiveness of a fin is increases if P upon ACS ratio ratio is greater than 1. Yes or no? Yes. Yes or no? Yes. अगर ये P अपॉन ACS रेशियो अगर ग्रेटर देन अगर 1 है, ज़्यादा है, तो इफेक्टिवनेस फिन का क्या होगा बच्चों? इंक्रीज होगा. और इफेक्टिवनेस किस पे, इस पे डिपेंड है? थर्मल कंडक्टिविटी पे. जो मटेरियल का थर्मल कंडक्टिविटी ज़्यादा, उसका इफेक्टिवनेस भी क्या रहेगा? ज़्यादा रहेगा. ओके, बिकॉज K is increases, effectiveness is also increases. Yes or no? Yes. So these are the some cases will be here. I write down here. If the ratio of perimeter and cross sectional area is increases, then effectiveness of the fin is also improve. So due to this reason, the thin and closely spaced fin are preferred. Okay, the lower limit on the distance between the two adjacent fins is governed by the thickness boundary layer developed on the surface of the fins. Means that's why the fin is very thin. उसके आपने देखा होंगे जो प्लेट्स जो रहती है, प्लेट्स जो है एकदम थिन रहती है फिन की, वो ज़्यादा उसकी थिकनेस नहीं रहती. द थिकनेस इज वेरी वेरी लेस. ओके, so this is the simple explanation about the effectiveness. Now our another point will be here. If you observe, suppose if you consider, it is also apparent that the use of the fins will be more effective with the materials of a large thermal conductivity. Okay, means this effectiveness depends upon the K also. If you consider the copper is most superior than what is aluminum regarding the thermal conductive point of view. But generally copper we cannot use. Why? Because the copper is very high costly. So therefore what is we use there? Aluminum materials. Okay, so generally all number of the fins are made by the which material? Aluminum materials. Okay, so thermal conductivity is improve, the effectiveness of the fin is also improve. Okay, so these are the some following points in the fin effectiveness, guys. Now another is very IMP topic is what is relationship between fin efficiency and what is effectiveness. This is very IMP equations which is asked in an exam much more times. So let's find out what is the relationship between them. If you consider the efficiency of a fin, so what is the formula for efficiency of a fin, guys? We already proved this formula. What is under root PH K ACS into T0 minus TA. Okay, tan hyperbolic ml. This is for which situation? This is the fin considered for insulated at a 1 T pence. We already know all the following conditions what we have to learn in our previous topics. Another is fin efficiency. Then another formula in bottom HPL T0 minus TA. We already learned this definition fin efficiency in yesterday. What is fin efficiency is defined as it is a ratio of actual heat transfer. We know fin efficiency is what is actual heat transfer upon what is maximum possible heat is transfer from the fin if entire fin area were at a base temperature, means Q actually upon Q max. So Q max formula is what is this one, HPL into T0 minus TA, and Q actually is this ones. Suppose this is equation number 1, guys. And we know the effectiveness of the fin. Now we recently calculated this effectiveness of a fin. What is under root PH K ACS into T0 minus TA, heat transfer with fin tan hyperbolic ml upon heat transfer what is without fin. So what is formula? H ACS into T0 minus TA. Suppose equation number 2. So what is we do here? Dividing equation 2 by 1. So what is we get? We get effectiveness of a fin upon efficiency of a fin is equal to what is? If you dividing all the things, what is you get? We get PL अपॉन ACS, क्योंकि बाकी के टर्म उसमें की कैंसिल हो जाएंगे बच्चों, आप मैथमेटिक्स करेंगे तो PL अपॉन ACS. So therefore effectiveness of a fin is equal to what is? N fin into PL upon ACS, guys. Okay, so you write down in this way what is effectiveness of a fin is equal to N fin multiplied by what is surface area of the fin upon what is cross sectional area of a fin, cross sectional area of the fin, guys. ओके, तो यहाँ पे देखेंगे अब कि इफेक्टिवनेस जो है, इफेक्टिवनेस डिपेंड्स है किस पे? फिन इफिशियंसी पे. फिन इफिशियंसी इंक्रीजेस, आल्सो इफेक्टिवनेस इज इंक्रीजेस. Effectiveness is also depends upon this ratio P upon ACS. P upon ACS increases, effectiveness is also increases, and effectiveness is also depends upon the length of the fins. Okay, so it is evident from the equation that an increase the fin effectiveness can be obtained by increase the length of the fin, but increase the fin but decrease the efficiency of the fin on other hands. Yes or no? Yes. So these are the some points we have to discuss, and the relationship in between the effectiveness and fin efficiency, guys. Yes or no? Yes. So I stop here. If you like my videos, so please share my videos with your friends or another college friends, and subscribe my YouTube channel to press the bell icon buttons. Okay. So stay at home, stay safe. Thank you very much.